Math 3, Unit 9, Section 8. Today we're talking about the application of logarithms. Okay, so starting here, the amount A an investment is worth is based on the principal P. So we have principal P, amount of the investment it's worth is A. Okay, this principal P, this right here, that is your initial amount. That's what you are starting with. So if you have so much money that you're going to invest, that's your principal. Okay, once you invest it, you want to figure out the amount that you have, what the investment is worth later. Okay, the interest rate, so the rate is R. The number of times per year is N. Okay, and what they're talking about is the number of times per year that they calculate your interest, the money that you have earned. Okay, so it's the number of times per year, and the investment is compounded, and the time, T, in years that has passed according to the formula. Okay, so nice thing is that we have been given this formula. Okay, so we are going to use the information that they're going to give us down here to plug into our formula. So what I like to do as I go through this is write what each of these numbers represents in terms of the formula. Okay, so if a person invests $700, where do you think, which letter would that represent? P. So when you're investing, that's your principal amount. Okay, and so right here, this 700 is P. Okay, in an account that earns a yearly interest rate, so we have our rate, which is 4%. Now, what you have to be careful of is that whenever you have a percent, you need to turn that into a decimal. And so that rate is going to end up being what? 0.04. So in order to change a percent into a decimal, you move the decimal 2 places to the left, and so you'd end up with 0.04. Okay. So first on part A, it says how much would this investment be worth in 10 years? Okay, so that is in terms of what? What would that represent? T for time, good. If it is compounded once per year. Now, compounding once per year, they're telling you how many times. Sometimes it's 12 times per year. Sometimes it's quarterly. Okay, so 1 time per year, that is representing the N. That's the number of times per year. So that means in this case, N equals 1, because it's 1 time per year. Okay, so far, do we have any questions? So now all we're going to do is plug this information into the formula that we have been given. And we are trying to figure out how much our investment is worth. That means we're trying to figure out the A value. So we're going to write this out. A equals, my principal amount was what?
700.
Very good, 700. Parentheses, 1 plus, and R is my rate, which is 0.04. Divided by N, which is the number of times per year that it's compounded. In this case, it's 1 time. And then it's raised to the number of times per year, which is 1, times the time, which in this case is 10. And then we simplify. Okay, so first of all, we would take care of our parentheses first. And so 0.04 divided by 1 is 0.04, correct? And then 1 plus 0.04 is, very good, 1.04. And then it's going to be raised to the 1 times 10 power, and 1 times 10 is 10. Okay, we would need to use a calculator for this. If you don't have one, you can go and get one. And so on our calculator, what do I need to do first in terms of order of operations? Very good. You have to do your exponent here. So we are taking 1.04 and we are raising that to the 10th power. Okay, and we get that answer. Once you take care of your exponent, then you can do the multiplication, which means we would multiply by 700. And we get the answer of, if we're dealing with money, where do you think that I should, how many decimal places should I go out to? 2. And so that ends up being 10,000, or not 10,000. No, it's $1,036.17. Are we good? Okay. So, you're investing $700, 4% interest rate, and after 10 years, you end up having $1,036. Okay, does that make sense? All right. So remember, this is telling you too, the more you invest, the more you can end up making. All right? Now, we are going to see what happens if it's compounded differently. So the next question says, how much would this investment be worth in 10 years? So again, we are still dealing with the 10 years, but this time it is compounded quarterly. What does quarterly mean? It's like you guys have it written right in front of you. I don't even know how you know that, but you're amazing. So since it's compounded quarterly, that's 4 times per year. That means in this case, n equals 4. So everything else is the same except for the n value has changed. Let's go ahead and write this out. A equals, our principal amount is still what? 700 times 1 plus, my rate is still 4%, which is 0.04, but this time we are dividing by 4 because it's compounded quarterly. And then it's raised to the what? Very good, 4 times 10. And then we're going to go through and simplify. I'd like you to write all this out here because you're able to see where these numbers are coming from if you go back to look at it. All right, so now I have A equals 700 times, we want to take our calculator and we're going to take 0.04 divided by 4, and we get 0.01 plus 1 is 1.01. So inside my parentheses is 1.01. Is everybody good with that? Okay. So 1.01, and it's going to be raised to the 40th power. So this is already in my calculator, 1.01, and then I can raise it to the 40th power. And we get that value right there. And then what do I do? Times it by 700. And what happens? We get a number, which is not 10,000. It is $1,042.20. Okay, $1,042.20. So right now looking, if you are making an investment, would it be better to have an investment where it's compounded yearly, once a year, or quarterly? Quarterly. You're going to make more money. The more often it's compounded, the more money you can actually make. So they're like looking at all the, like it's like they're basically doing this calculation and then that's how much money you have. Does that make sense? So you'll get more money into your account every time they compound it. Okay. How much would this investment be worth in 10 years? So again, we are still dealing with 10 years, but on this one, it's going to be monthly. Do we know how many times a year that would be?
6. Maybe 12.
Okay, so some of you said the correct answer and some of you didn't, which is slightly scary. But there are 12 months in a year. So everything's based on a year, and then we have to figure out how many times within that year. Okay, and if you know the months of the year, they, in terms of numbers, they go 1 to 12. And so therefore there are 12 months in a year. Okay. All right, so we're using the same information and we're just plugging into this formula, but this time n equals 12. Okay, I'm going to give you a minute to try this one on your own. Since we're doing with money, we're just going to go out to 2 decimal places. But if you want to do 3, that's fine too. Did you get the answer? No, my eyes are horrible. Did you get it? Oh, so this one, it's compounded monthly, so it's gonna your N is gonna be 12 for 12 times a year. Okay. So on this one, it's like $1.18 more than Part B. Oh, maybe not. I meant 38 cents more. $1.38 more. My bad. Nice. Okay, so this is how you should have set it up. What would be the first thing you would solve on this problem when you're trying to figure it out? Parentheses. And so you would take 0.04 divided by 12. And you should have got that value, and then you add 1 to it, and so we have 1 point. What would happen is I would actually leave this in my calculator to make it more accurate. Does that kind of make sense? And so, but on here, I'm going to write 1.003, something like that. And it's raised to the 120th power. So all we do is take that answer, and we raise it to the 120th power, and we get that value, and then we multiply it by 700 to get $1,043.58. Do we have any questions about that? Okay, if you didn't get it correct or didn't get the same answer, maybe you didn't leave the number in the calculator. It would change it by a few cents probably. So if you can, always just try to leave information in without rounding until you get to the very end. Okay, this next problem, we have a different formula. Okay, and this still has, you're figuring out the month and the amount an investment is worth. Okay, if it's compounded. Now this is saying that it's compounded, do you see that? Continuously. So that means like all the time it's being compounded, okay? And so the banks and stuff have these systems that do this all the time for your accounts, if they have an account that's compounded continuously, okay? Same thing, it's worth is based on the principal P. So principal is always our initial amount, very good, okay? And the interest rate R, and make sure we always put that into a decimal, was what I was looking for if you said that. And time T in years that is passed according to the formula. So here we have this formula right there. Yes? Do you have a question? Okay, and then E we know is actually a value, just like pi, right? It's on your calculator. Yes. Okay. Here we go. Are we ready? A person invests $500. So this $500, what does it represent? Very good. 500 is principal, P. And a bank that has a rate of 2.5%, which means what? R. And how would I actually write R? Very good. We move this decimal 2 places to the left, and that's 0.025 for your rate. And it's compounded continuously. Because we know it's compounded continuously, I need to use this formula right there. Okay? So write an equation for the amount this investment would be worth after T years. So right now, they aren't wanting you to actually find an answer. They're just wanting you to write out the formula with the information they've given you. Okay? So I would write what? So since we're investing $500, we don't know what A is, correct? So we're going to write A equals 500 E to the what? 0.025. We want to make sure we write that as a decimal and not a percent. And then they said just to write it for T years. So there is T. What? Okay, next. How much would the investment be worth after 15 years? What will we do for the 15 years? Very good. Put 15 in the T spot. So T equals 15. So we already have this all written out. All we're going to do is plug in that 15. A equals 500 times E to the 0.025 times 15. What do we need to do first? Yeah, you could do that. So, okay, if we do it this way, 0.025 times 15, we get 0.375. Is that what you guys have? A equals 500 times E to the 0.375. What would I do now? Okay, so on your calculators, you need to find the button where it says e to the x. Do you guys see it?
Yes. Yeah.
So if you find your natural log, right above natural log is e to the x. Okay? So in this case, I have to do second and press that. And do you see how it has e and then the caret? Okay. So, yeah, I think it has the caret symbol, right? I don't know. Okay. Is there another word for that I don't know? Arrow? Okay, sure. All right, so we end up getting that value. Now, what you could have also done is when you did e to this power, inside the parentheses, you could have put 0.025 times 15 and then close your parenthesis and you get the same value. Either way. And then once I have this now, what do I do? Times it by 500. And we get what? Very good. And when you're rounding this, it's going to end up being what? 50. Okay, so my amount ends up equaling, bless you, $727.50. Okay, now this next part, they are asking you, determine the amount of time. So right there, we know that the variable we are going to try to find is what? T. Okay, this is what we want to find, T this time. It will take for the investment to reach $700. So that means $700 is going to represent what? The A, the amount I have. So A equals the $700. And then it says round to the nearest tenth of a year. We're using our same formula. It's still compounded continuously, but this time we're just going to figure out, okay, I have $500. I want to make that $500 into $700. How long do I have to leave it in the bank account? Okay, so here we go. We're going to write this now. So instead of writing A, we're going to write 700. So 700 equals 500 times E, and we already figured out all that other stuff. So we have our 0.025, but what will I use? Instead of 15 this time, I'm going to put T, because we're trying to find the T. Are we good with that? How will I find this answer? Well, we know that right now, this is together, right? E is going to that exponent. So I need to get rid of that $500, or that 500. 500 is multiplying, so how do we undo multiplication? Okay, the divide that I heard was correct. You undo multiplication by division. So we're going to divide by 500 to both sides. Okay, so if you divide those two, what do you get? Good. you end up getting 1.4 equals e to the 0.025 t. Who knows what to do at this point? We want to get t by itself. Okay, we're solving for t. And the only way to do that is by introducing logs. We have already been solving problems like this. It's going to be a natural log. Great. How do we know it's going to be a natural log? It's base e. Okay? And so, if we were to do this, we're going to change this into log form, right? Change into log form. Make a note to yourself. I'm going to put log / natural log form. Okay, so how will I write it? Natural log, which is base e. Do I have to write base e? No, you can if you want to. Of what value? 1.4 equals, very good, 0.025 t. And if we want to get t by itself, what will I do next? Very good. Divide by 0.025. And while this looks super complicated, we have this thing called a calculator that makes it relatively simple. Okay, so we have a button that has natural log. So we press it. And then what do we put in? 1.4. Good. And we press equals. And we get a value. And then what do I do with that value? Divide it by 0.025. And we press enter. And I get what? 13.5, because it says round to the nearest tenth of a year. And so that means my time is 13.5 years. Now, if you look back at the previous problem, they had this value in the bank for 15 years and it made $727. We want to make $700, and in order to get to $700, it takes 13.5 years. Does that make sense as an answer? That it would take less time to get to 700 than it would take to get here? Yeah. Okay, do we have any questions? All right, let's move on to that last problem here. Okay, so this time they have not given you a formula, okay? But there are only two formulas we're going to be using, okay? So one of them is if you're compounding continuously, and then the other one is if you're compounding a specific time during the year, okay? So when we read at this one, first of all, it says an investment of $350. What does that $350 represent? Which letter? P. Very good. So P equals $350. Okay? Is made at 3% interest. We're going to go ahead and just do that. That doesn't say rate, but 3% interest. They're talking about the rate. And how would I write that? 0.03. Okay, so we have our rate as 0.03. And then it says compounded quarterly. Okay, what does that tell us? Very good. And that's specifically n equals 4. Because it's being compounded quarterly, we know that we are going to end up using this formula. Okay, so we're going to go ahead. I'm going to write it to the side here, what that formula is. And that is A equals P times 1 plus R over N raised to the NT for N times T. Okay, so A asks you to write an equation for the amount this investment will be worth after T years. So we're going to write that formula. So I'm giving you guys a minute to write the formula, and then we'll check to see if you're correct. I'm sure you got it. Okay. Formula should be A equals what? 350. That's my initial amount, my principal, times. Very good. 1.03 divided by 4 raised to the 4t. Well done. Could you simplify this if you wanted to? Yes. So another acceptable answer would be A equals 350 times, and if you put in your calculator 0.03 divided by 4 and then you added 1, you would end up getting 1.0075 raised to the 4t. Okay. Any questions? All right. How much would this investment be worth after 20 years? What will we do?
You plug in it for T.
Very good. So, A equals 350 times. I'm going to do 1.0075 times 4 to the, or 4 times 20 power. Did you guys find the answer?
Yes.
What is the answer? Very good. So A equals 350 times 1.0075 to the 80th power. Order of operations, you have to do exponents first. So you should have put in your calculator 1.0075 to the 80th power and then multiplied by 350. And the amount you end up having remaining is $636.32. All right. Last problem. Determine the time. So when they say determine the time, that means that we are going to be finding what? The T. We need to find the T. It will take for the investment to double. What does double mean for this problem? It means times 2. So what's my initial investment?
636.
My initial investment is... It's okay. My initial investment is 350. So when you're doubling that, that means you're going 2 times 350, which is how much? $700. And so 700 is going to be which value? A. And then it says round to the nearest tenth of a year. Okay. How will we write this one out? Okay, 700 equals 350 times over 4, because it's still compounded quarterly for this problem. Okay, and then it's raised to the 4t. Okay, what do you think we do first? What'd you say? Okay, we could divide by 350. And so we have 2 equals. Can we add these together?
Yes.
Okay, so we add those together and what do we get? 1.0075 raised to the 4t power. Okay, now what? How can I solve for t? We have to change it into log form. Okay, so there's no e's here, so that means we're going to actually use logs. And we would write this as log base what? Yeah, it's this, log of this. Log of 1.0075 of 2 equals 4t. How can I find this out? What do I have to do? Because on my calculator, it's always in log base 10, correct? This is not log base 10. How do I change this? How do I change it to be the correct base? What do I do? This goes back to yesterday. Yeah.
Log of 2.
Good. Log of 2 over
Log 1.
1.0075 equals 4t. Do you guys remember that now? So this is, we have to use change of base. Okay, can we do this in our calculator? All right. So we take log of 2, press enter, we get that value. Then we do what? Divided by log of, close the parenthesis, equals this value. Okay, now again, I would probably leave this in my calculator, but I would still write something down. And so I'm going to write down, like, if we round it to the nearest tenth, I guess, 92.8. 92.8 equals 4t. And then in order to get t by itself, what do I do? Divide by 4. But in my calculator, I would leave it like this and press divide by 4 and 23.2. T equals 23.2, and that is in terms of years.